This is Scott from KIG. It is February 21st, 2017. We're going to do a brief runoff video on this 3 horsepower Glycol chiller. This unit's one of our favorite units in recent history, just because it's so nicely made. It's never been used. It's a 3 horsepower Edwards Engineering. I think those are made in New Jersey. They're made in the US either way. Model CF03, serial number 077620. This is a 208 single phase voltage unit. We've been running it for a while with the set point set kind of high so we can pull down the tank on this brief runoff test here. What we have here inside the control cabinet is a super nice multiplexing kind of display. It's in centigrade, but it shows things like your compressor discharge temperature, compressor suction temperature, liquid line, coolant return, coolant supply, and condenser coil temperature. Because we're not running or chilling right now, those are all very close. In addition to those 6 temperature parameters, which are outstanding if you ever have to troubleshoot with somebody over the phone, we also have the refrigerant pressure gauges also. In this case here, the thermostat, which controls the temperature on the unit, is a Johnson Controls, just with a rotary dial right here. Right now we have it set up at approximately 25 C, just so we can heat up the tank right now, but right now it's showing the temperature at 16 centigrade. It is fairly sensitive, but we want to bring it down right about to that -2 centigrade mark. You can see there you have -5 and 5, and we want to bring it down just right to about there. We can tweak it. You know, once we meet our set point, we want to chill at about 28 Fahrenheit, which is -2 degrees centigrade. You don't want to go much colder than that. In fact, if you can get away with a little bit warmer, that's ideal. You want to have it at the warmest set point temperature that satisfies your brewery glycol loop. Because the colder you run, the harder the compressor is going to work, and at the end of the day, the less BTU capacity you actually have. So we can hear some noises. The compressor started and the fan started. And before we go look at some of those things, I just want to talk about a couple things in here. That's your main disconnect. We manually turned that on so we could have the cabinet door open. You shouldn't have the cabinet door open and power on the unit. Again, the temperature controller. This here is the low ambient P66 fan speed control. That's so you can run this in colder climates or colder ambient environments. This one's probably going to go indoors, which is fine, but it's nice to know you have that feature. This here is our high and low safety pressure switches, and they're pre-adjusted from us here to run at glycol temperatures. They do a nice thing. They put a pressure temperature chart here. That's outstanding, again, if you're on the phone with us troubleshooting for any reason. And they really put a nice placard here, kind of almost like an engraved plaque for the wiring and piping schematic for this unit. Now that we started to chill, you can see we have condenser coil temperature, coolant supply, so that means that's a sensor that's sensing the output. We're down to 11 C already. Coolant return, 10 C. We really don't have a load on this, we're just cooling the tank, so that should be about the same. The liquid line, that's basically what's coming out of your condenser coil. So the refrigerant's going into the condenser, and that should come out a little bit cooler than what's going into it. Then you have the compressor suction temperature, in this case 1 degrees C, okay, and the compressor discharge temperature 38 degrees C right now, while we're cooling at a glycol temperature of about 9 degrees C. So again, we want to see, we want to run this down and maintain for, you know, minus 2 degrees centigrade, which is about 28 degrees Fahrenheit. And we may have to tweak that adjustment a little bit when we're doing that. So this unit, our incoming power, it's single phase. We're just using our own cable right now. Okay, it's single phase, so we don't have to worry about rotations. You have a ground right here, and then you just have your two hots. All right. So let's talk about some of the components of the unit. We love this frame design here. Right now you can hear the fan, or see the fan kind of cycling speed on and off a little bit based on its load. You have a nice insulated reservoir here. The heat exchanger, the refrigerant to fluid heat exchanger, is actually inside that insulated tank. You have your 3 horsepower Copeland scroll compressor here, and that has a heater band on it. As long as there's power to the unit, and you always should have power to the unit, that heater band's going to be on. And so when the chiller's turned off from a set point standpoint, that compressor heater will always be on, keeping that refrigerant nice and warm in the bottom of the unit. That's your thermo expansion valve. And above that is your refrigerant sight glass, which can be used for troubleshooting. In case you ever think there's a refrigerant leak down the road. So you have your drain. And we do have all the side covers. For this test, we can have the side covers off. However, the top side covers on a unit like this, the top side covers should remain on. So here we have our pump. Our pump draws from the tank here into the pump, okay? Then it comes here out to your process. In this case here, we're going through, just created a loop, and we're going through our flow meter and pressure gauge. There's an internal bypass here, and leave that kind of cracked half open upon initial startup. And then this is your return. It comes back and discharges back into the glycol reservoir. We have a pressure relief valve here, just for excess pressure in the tank if needed. And then you also have your glycol reservoir. We got about half full right now for this testing. So this unit with the heat exchanger submerged in the tank, again, we're drawing out of the tank, out to your process, and then discharging back. We can discharge back at very, very low pressure into the tank because we're not pumping through like a braze plate heat exchanger or anything like that requires a significant pressure drop. So right now, well, we chilled our contents of the tank down about 3 degrees C. We're going to come back with video number 2 after it's been holding and maintaining minus 2 degrees C for some time. Thanks.